A lot of really important information can be gleaned from an NMR spectrum. So first of all, the number of signals, and this tells us how many unique protons are in the molecule. So if you take a look at the spectrum down here on the bottom, you see that we have sort of three groups of lines here. So we have a group here, we have another group here, and there's another group here. So each one of these groups of lines is called a signal. Then in this NMR spectrum, there are three unique types of protons in the molecule. The next piece of information that we can get from the NMR spectrum is the chemical shift of each signal. And what that tells us is what the electron environment is like for that proton. So the chemical shift you see is reported in ppm, which stands for parts per million. So I have one set of signals that's around 7.2 parts per million. I have another signal around here, which is around 2.6 parts per million. And I have a signal down here, which is around 1.2 parts per million. The next piece of information is the integration of each signal. And that tells me how many protons of a particular type are represented by each signal. The area under each signal indicates the number of protons giving rise to that signal. So a computer is used to actually calculate the area under each one of the signals, and that data is provided to us on the NMR spectrum. The last piece of information is the multiplicity of each signal. What that tells us is how many neighboring hydrogens there are. So I know that right now this might just look like a bunch of squiggly lines, and then this is another set of lines, and this is another set of lines. But if you take a look at this set down here, around 1.2 parts per million, you can see that that's three peaks, and we call that a triplet. You can see the peak that's around 2.6 parts per million, or the signal around 2.6 parts per million, is four peaks, and we call that a quartet. The signal above 7 parts per million on this proton NMR spectrum is a little bit difficult to decipher, so we would just call that a multiplet. And the point is that we're going to figure out how to determine what the triplet and quartet and multiplet represent. And again, what they will tell us is how many adjacent hydrogen atoms there are.